Hi, we're Team J-Rads, and my name is James Houghton.
I'm Robert Javier.
I'm Amy Com. I'm Dana Markson.
I'm Stephen Mangley.
When it comes to suspension systems, there are two categories, dependent and independent. So in a dependent system, the wheels are connected by an axle, so any force on either wheel is transmitted to the other wheel as well, which this isn't ideal, which is where independent systems come in. In an independent system, the wheels are independent of each other, so they're not connected by an axle, and this makes for a smoother ride. And a common independent suspension system is called the double wishbone system, or A-arm. And in this system, there's a spring and shock absorber that is located in between the upper and the lower control arm. And these control arms are shaped like wishbones, which is where the name comes from. And usually the upper arm is shorter than the lower arm, and this is so that you can control factors such as the camber angle, and this particular suspension system is effective in producing negative camber due to the shorter upper arm, because as the wheel moves upward, it also moves inward, which helps. So when a car is going around the corner, this helps keep the tire flatter to the surface and maintain stability of the car.
Another type of suspension that we researched was a hydraulic suspension, and one type of hydraulic suspension is a twin tube suspension, which has one smaller cylinder inside another one, and it is filled with fluid, and the fluid is usually oil because it runs very smoothly. In the inner cylinder has a piston inside of it, which is connected to the piston rod, and then the piston rod is connected to the axle of the actual car. So as the car goes over like a bump or anything in the road, the piston moves down, and the fluid keeps it from going down too fast, and then it'll flow through these valves up into C, which is in between the smaller cylinder and the larger cylinder. The piston will move up and down at this rate, and the oil helps it flow nice and smoothly, so it's not too fast and not too slow. The suspension is put under pressure, so the oil does not foam or bubble, and that would allow it to keep it from moving smoothly. Some advantages are that it has very good road clearance for vehicles that are very low to the ground, and fluid allows the piston to compress with very little resistance, and also it lasts very long because there's no rusting or anything, because it's just a fluid. It also reduces noise in the car. Some disadvantages are that the fluid could leak, and if the fluid leaks, then your car has to get maintenance right away. Also, it can only be mounted in one direction because it is fluid. It's not just anything, so it can only be mounted straight up and down.
So the mini Baja system that they use here has a standard and basic design for the suspension system. Basically, they have springs attached to struts to allow for more structural support and reduces the chances of tipping the car over. The system also allows for good shock absorption, so this allows for a more smoother ride when driving the vehicle. The system is also connected by an upper and lower control arm to the main body of the frame. There are also some weaknesses in their system. For one, there is a lack of rubber cores in the struts, which increases stress on the coils of the vehicle. It also increases the positive camber, which can lead to tipping of the car when making turns.
The current vehicle, we were told, has a problem going around turns. It produces a positive camber. This is when the top of the wheel goes outwards, and it is a result of the force when the vehicle goes around the turn. The wheels turn, but the vehicle's momentum is still going in the same direction. So there is a big force outward away from the vehicle in the turn, and this puts stress on the tires, and the tires can turn and aren't even on the ground anymore, and this results in a loss of friction, and the vehicle could tip or just slide and spin out. So for our suspension system, we made uneven control arms. We made the top one a little bit shorter so that the vehicle naturally rests with a little bit of negative camber, so that the top of the wheel will be facing inside. This helps because the vehicle, when it goes around sharp turns at high rates, the force will still be there, but instead of the wheel going outwards, it will go back into an upright position. And since it'll be flat on the ground, there will be an increased friction between the tire and the ground, so you'll be able to take the turn a little bit faster, and also the suspension system won't be compromised because the wheel is in an unnatural position.
Okay, so the redesign of the mini Baja suspension system, we decided to do a coilover system. The nice thing about the coilover system is its adjustability. You can adjust the spring length and how stiff it is. This means better handling. It means a lower center of gravity if you decide to lower the springs, which gives you less chance of tipping. And it removes stress from the suspension system by adjusting the stiffness of the spring. But the problem with this is it's more expensive than just lowering the springs. Coilovers cost about $1,500 compared to lowering springs, which is about $200. Okay, so for the mini Baja suspension system again, we had uneven control arms. This actually increased the negative camber gain because the upper arm was 1 inch shorter than the lower arm, and a 15-degree negative camber angle. And the suspension system they had was an A-arm suspension, which was, I believe, a wishbone talked about. Nice thing about it, it had a more central loading point. And just for visual, this is a suspension bushing with a coilover suspension. It was designed using rapid prototype techniques. It goes on top of the suspension system and holds the suspension system to the chassis of the car.
This is the new suspension system that we made. The blue components are the new control arms we redesigned. As you can see, the upper arm is shorter than the lower arm to give the wheels more negative camber, about 15 degrees in difference. The red coils were also redesigned to be longer with a large bushing mounted between the chassis to provide more support and additional shock absorption.